We have the unit connected to a test box to allow us to put simulated inputs into the unit, and we also have a number of switches and potentiometers connected so that we can switch between the various operating modes and use the potentiometers to control the brightness. So let's just go ahead and just zoom in first of all so that we can get a better view of the unit itself. The lighting's not ideal. Okay, so let's go ahead and apply power to the unit. When we apply power without any of these switches pressed, it'll come up in the normal operating mode. The first thing it will do is display the software version, which is 0.3. Now, we currently have the 4-digit display. Let's look at that first of all, displaying voltage, supply voltage. So if I vary that, we can see that the bar gauge, the upper bar gauge, goes down with voltage, and the numeric display varies as well. We can take it up. See, if it goes out of range, we get an audible warning and the power LED flashes. If it goes out of range low, the same thing. So let's set that at about 13. The second bar gauge is throttle position. So if I move the pot that varies throttle position, you can see that going up and down. And we can actually change the numeric display to indicate that function as well. Which is that position. So throttle position goes from 100% to 0. And in fact we have a little dead range on the bottom and the upper range. So if it goes too low, like a short circuit or an open circuit, it will also give an audible warning. The lower bar gauge is outside air temperature. So we can vary that as well. And again, we can change the numeric display to indicate the outside air temperature. And we can switch that display between Fahrenheit and centigrade. By a long press on push button number 1. All of these instructions are available on the website. So that's the numeric display and the bar gauge displays. Let's put that into voltage for a moment. We've seen that this indicator here is the power LED, and that indicates a constant light if the voltage supplied to the unit is within range. If it goes out of range, high or low, it's going to flash. We then have these normal, auto and pursuit indicators, which are connected to ground switched inputs. So moving between normal and auto. If we put the pursuit input on, it will go straight from either normal or from auto to indicate the pursuit LED. These green-red indicators are just ground switched inputs which can be connected to anything that you like. So when those inputs are not connected to anything, they're red. When they're connected to ground, they go green. Then you can reverse that if you wish. We can just reprogram that to give it a red indication for a ground switched input if you so wish. What else can we do? We can put it to show mode by a long press on this button, and that will just put the unit into a randomly cycling display, which is probably a good thing for car shows and so forth. We can switch back to normal running mode quite easily. You see, you get a momentary indication of which mode you're going into as well. We also have 2 other modes which are mainly used for diagnostic purposes. So let's just take a quick look at those. So this is output test mode, which just goes through every LED on the display to make sure that they are working. It puts a number of random patterns on as well. So it tests each LED individually at each segment of each LED. It then tests the entire display and varies the brightness. Varies the brightness of the numerics, varies the brightness of the other LEDs, the light bars. Those brightnesses can be varied using these potentiometers as well, so we'll just have a look at that in a moment. See, it also has an audio tone generator, so this is just testing out all of the audio tones that it can produce. Then it'll go back round again. The other functional mode that we have is input test mode, which we can get into like this. Now in input test mode, this display, this numeric display in input test mode, is actually looking at the hexadecimal value of the analog inputs. The 0 indicates which input, so input number 0 currently has a hex value of C5, and input 0 corresponds to the throttle position sensor. No, it doesn't. I'm telling you an untruth there. Analog input number 0 corresponds to potentiometer number 0, which you can see varies as we change that. Now normally, in the normal running mode, these potentiometers vary the brightness, but we don't want that to happen in the input test mode. We want to actually see the value being read by those inputs. We can vary which input is being looked at. So input number 1 is the other potentiometer, which is the brightness of the light bars as opposed to the brightness of the numerics. Press it again, and we're now looking at the throttle position sensor, which when we're in input test mode is the upper gauge, and the flashing LED indicates which bar gauge is being displayed in analog value there. So you can see if we vary it, the bar gauge will go up and down, and the hexadecimal value being read by the onboard converter will also vary. Press it again, we're now looking at this bar gauge input, which is the air temperature sensor. And press it again, we're now looking at the voltage supply to the unit. Again, vary that up and down. So that's about it. Let's go back into normal running mode. And while we're in normal running mode, if we vary these potentiometer inputs, you can see that we can vary the brightness of the numeric display independently of the brightness of the light bars. So you can get those to a pleasing value from minimum to maximum. If you don't connect these potentiometers at all, it will just run in maximum brightness. So that's a quick overview. Further details will be on the site.